So the 2 points listed, there's 3 versions of this graph. They're all the same graph. We're just going to do different things with it. They're all based on the data at the top of page 2. You get that data from page 2. We're going to type that in, and we're going to make some calculations. So the years I'm working with are 2010. Populations are 5.9 million and 6.7 million, which we're going to type as regular numbers. So get all that typed in there. It would be a good idea to format your populations as numbers so that you can see those commas. If you need help doing that, let me know. Are you using Google Sheets or Excel? Google Sheets. I like both numbers. Excel the backwards. I did, and I didn't write back. I meant to. Sorry. But I got your message. All right. Extra zeros there. All right, so hit enter on yours. Hit enter first. Highlight both cells first. All right, and then go to where it says general. It's not currency. They're not dollars. Here we go. Use comma separators. All right, custom format there. All right. What we're going to do is we're going to calculate the absolute change. So the absolute change is going to go in the same row as 2010, because we want to find the difference between the 2010 population and the 2000 population. So write a formula that subtracts those two. And hopefully you'll end up with 800,000 in the absolute change cell. And we want to put that in that third row in line with the 2010. Because the population jumped from 2000 to 2010 by 800,000. I mean, you could put it in the previous row, but for me, it feels better there. So it went up by 800,000. Okay. Subtract those two populations. If you get a negative, you subtract it in the wrong order. So remember, spreadsheet is a calculator. We never want to type something manually like that. 800,000, we want the computer to calculate it for us. All right, next column, let's do the relative change. Relative change is where we take the absolute change and divide by the original population, the 2000 population. And we usually like to state that as a percent, so then reformat it as a percent. You can't do it automatically there. You just have to hit enter to fix it, and then click back on it by using the percent button at the top. It's the 8,000 divided by the original population, the 2000 population. Yeah, And you should get about 0.13.
Minus.
Yeah, so we can just add more decimal places. So if one of these decimal places. Yeah, so here I've got it to the nearest 100th of a percent. So as far as predicting the 2020 population, we've got a couple of different ways we can do it. We can say, hey, let's just assume the population is going up by 800,000 every 10 years. Okay, so that's one way we could do it. Or we could say the population is going up by 13.56% every 10 years. Talk about it as percent change or amount change. What's the difference? Well, think about running a store. Usually a store does something like 50% markup or 100% markup. Okay? Can you imagine a store saying, I'm always going to mark up by $1? Right? It's usually percent markup that we do. Well, the same thing happens with population. When we're looking at population changes, we usually talk about percent change. But we're going to take a look at it both ways. So first, so at the bottom of all your sheets, it should say sheet 1 on a little tab down there. We're going to change sheet 1 to absolute. You just double click on it and give it a new name. So instead of sheet 1, it's going to be called absolute. In a minute, we'll make a copy of this sheet, and we'll do percent change on that in a minute. So next, we're going to predict the 2020 population. In 2020, we're going to assume that the population is going to continue to rise at 800,000 people every 10 years. So we would just add to the 2010 population that 8,000. So I'll write a formula that goes equals, take the 2010 population and add my absolute change. So I just click on those two cells. So I go equals, click on cell B3 plus 3. And if we assume it continues to go up by 800,000 every 10 years, then those are the numbers I'll get. So now I want the computer to graph them for me. Now before I do that, does anyone need help getting those formulas or numbers to work out? Everyone have 7,500,000 for the 2020 population? Okay, so next we're going to do is in A1 I have the year, the population, and all of the numbers underneath. So basically all the data in columns A and B. So I'm going to use my mouse to highlight those two. So to do that, I start by clicking in the middle of cell A1 and drag over and down. All right, so I think you're clicking in column A. So, oh, I see what you're doing. Yeah, we don't want to do that. So undo it and just go there. Control Z on the keyboard. Okay, so let's click on year and then just click in the middle of the word year. Drag over and down. Over one cell. Okay. Yeah, so we just want that highlighted. Once we do that, we want to make a chart. And Robert, I'll help you in just a second on that. In Google Sheets, for those of you doing Google Sheets, there should be a chart button somewhere in the upper right. It says Insert Chart. Or you can go to the Insert menu and choose Chart. And I'm going to zoom out to do this. All right. And then in a minute, that'll pop up. No, oops, you moved it. Oh, you hit Insert still. Okay. So just do Control Z a few times. So Control Z once, Control Z undo. Okay. We want to go to Insert. And then here we want change those words. Recommended charts. Okay. Now you got the right chart, so hold it right there. So the next thing we want to do is in Google Sheets, if you're doing that, you want to choose, it says column chart. So click where it says column chart in Sheets. That'll give you a list of other kinds of charts. You're going to scroll down until you see scatter. It just plots them as points. The first column is the horizontal stuff. The second column is the vertical stuff. So this is plotting year at the bottom versus population vertically. Okay. Excel, it looks like it automatically picks that if we use recommended charts in Excel. So in Excel, we go to Insert and then Recommended Charts, and then just click. All right, for those of you in Sheets, what we're going to do is next is we need to customize this a little bit. So We're in the data tab right now. If you switch over to the customize tab, I'll explain how to fix yours in just a second, Robert. We want to add some titles so it's readable. So if you click on chart titles, under chart title text, we're just going to put Washington. I'm just going to go WA for Washington population. And then right above Washington population, it says title text. Above that, it says chart title. If you click on chart title, it'll let you put other titles in, like a horizontal and a vertical axis title. So next, I'm going to do the horizontal axis title, and that one's going to be year. Question? You're not seeing that?
No,
Yeah, that's okay. And yeah, so put a legend in there. I'll talk about the legend in just a minute. You type things in there. So we want to, that's okay. We just pick the horizontal axis. All right, so for Robert to do that, yeah, we'll do that in just a minute. That's pretty cool stuff. Okay, you got chart title in there, so that's good. Let's just call that good enough right there. You are in Excel. Okay, so in Excel, if you put a plus there, you can get to edit stuff, so you can put in chart titles and the arrow key options. You can do access titles too. So you have your chart titles, you have the access titles. The arrow points, that's the arrow. You have no options. And then from there, you can put in state text options. So then once that's in, you just come back to the chart. So now you have your front years. And then you can edit the other one to say population. All right, so let me just finish this. Let's see, year there. So then from horizontal axis, I switch to vertical axis. And the vertical axis is number of people or population, whatever you want to call it. I'm going to call mine people. Is in that label. So again, we chose, yeah. So you put that on that, so we put background titles. And you switch from horizontal to all right, Robert's having fun with colors. Cool. Tristan, you doing okay over here? Okay. All right. So some other things I'm just going to adjust on here. So to close the options for chart title, I just click back on chart title and it minimizes it. Down below there, it says legend. So a legend is when you have different kinds of data on the same graph and you do a color code to know what's what. So for example, on mine, it's showing those blue dots, and in the upper right corner, it says those blue dots represent population. Since I only have one color, I do not need a legend. Okay, so we're just going to turn the legend off. So I'm going to go from legend position right. So I have to click on legend, position right, change to none. That'll get rid of it. Your Excel didn't put a legend in there because there was only one data set. So here on yours, you can just turn off. Because there's only one kind of data here. So about these 3 points here. They're going up, and they're going up in a straight line, right? So we can tell the computer to graph that line for us. That's what we're going to do on paper in a minute for question number 5. So to tell the computer to graph that line in Google Sheets, what we do is we go to the series option. So we're under Customize, Series, open up Series. It says Trend Line as one of the options. We want to turn on the trend line. And there's different types of trend lines. There's linear, exponential, polynomial, logarithmic, power scale, and moving average. We're doing a linear one, straight line. Okay. Under that, for label, we want to see the equation. So use equation for label. So see if you can make that happen. And I'll talk about what that means in just a minute.
All right, on yours, so we have that option. Trend line. Oh yeah, there you go. So hit that tab. Then we're going to need more options. And then we want to display. All right. So in Excel, it's pretty similar. You point to the chart, you hit the plus. You want to hit the arrow by trend line. And go to more options. And under more options, you want to show the equation, display the equation on the chart, at the very end of the options. And that'll show the equation.
The important thing. So I'm just going to take a screenshot of that and bring it to my worksheet. And I'll talk about what that means. So we put the legend back in there, which is fine. Page. So you may have seen things like this before. Equations of straight lines. Look like y equals some number m times x plus some other number times b. The m number, that's called the slope. Slope is rise, that's the vertical change. For us, that rise over run is change in population, right? So I have a change in population for the rise over a change in years for the run. And it says, how many zeros are there? 1, 2, 3, 4 zeros. So we've got 1, 2, 3, 4 zeros. So that says 80,000 people here, because there's no denominator, we can divide by 1. Now, what did our table say the change was? Our table showed that the change was 800,000 people every 10 years. Is fractions the same or different? Is 80,000 people every 10 years the same as 800,000 people every 10 years? Is that the same as 80,000 people per year? And we lose a 0. So these are the same. Right? And the thing about straight lines is the slope is always the same no matter which 2 points you pick. So if I pick these 2 points, I get a change, a rise of 800,000 divided by a run of 10. That simplifies to 80,000. If I was just going to go from 2010 to 2011, that would have a rise of 80,000 and a run of 1. Go from 2000 to 2020, what's my rise going to be there? To go from 2000 to 2020. It's going to be what? Almost. It's going to end up being 1.6 million. So the graph's not quite showing us accurately. Google decided to give us nice numbers, but we're going up 800,000 every. We went up 800,000 to here, and another 800,000 to get to that one. So altogether, we went up in 600,000. So that's our rise. And our run is going to be 20 years. And if we divide those two numbers, 80,000 per year. Right? And that's the thing about a straight line. No matter what 2 points you pick, if you divide the vertical change by the horizontal change, you're always going to get the same answer. Now, this other number, the b, that's the y-intercept. Okay, so just a note on y-intercept. Sometimes that's a useful number, sometimes it's not when we do models like this. So b is part of the y-intercept. It means we have the point 0 and whatever b is. Okay, so 0 for us, that's a year. Think about, what does year 0 mean? Let's see, we just plotted 2020, which is in a few years. Year 0, that's when we switched from AD to BC, or BC to AD.
Right, that was a long time ago. Did Washington even exist then? Yeah, so that our y-intercept is actually meaningless, but it's what makes the line the line. Right? So we have to throw it in there to make the calculation right, but for us, it doesn't mean anything in this case. There's no population of Washington. Well, there were probably people here, but it wasn't Washington then. Okay. So in this case, that doesn't help me. Sometimes the y-intercept is meaningful in problems like this. It just kind of depends on the problem. All right. So what I want you to do next is take out your piece of paper and find yourself a straight edge. I can go grab some rulers. You're going to draw a nice straight line from the first point to the second point for number 5. On the worksheet. So get out that worksheet. And on number 5, we're going to reproduce what the computer just did for us. So number 5 asks us to use the absolute change to predict the population in 2020. To do that, we're going to use a ruler to draw a line between those points. So I'm going to try and do it virtually here. Back a couple slides. All right. Let's see if I can use my straight line tool. Magic board here. And just draw that straight line straight through off the edge there. And we see where it ends up. So mine ends up, it looks pretty close to 7.5 million, 7,500,000. And if I look back at what the computer predicted, it looked like, didn't it look like 7.5 million? Yeah. Now, we know it's actually a little different. It actually is 7.6 million, but on this scale, it's pretty close. So that's using absolute change. Absolute change means we're making a straight line. Okay. Do you think populations change as straight lines? Sometimes, sometimes not. Most of the time not. Okay. So we're going to do a different prediction next. So we're going to repeat this. So go back to our spreadsheet. Find my spreadsheet. There it is. So if the graph is covering up your stuff, we can just move it out of the way by clicking once on it, clicking again, and dragging the white space. If you're in Google Sheets, you can get the chart editor out of the way by just clicking on a cell or clicking the X in the upper right corner of the chart editor. So we're going to make a new tab. In that tab, we're going to copy some of this information. I'm going to highlight cells A1 through D3. A1 through D3. And then I'm going to copy those. So Control-C on the keyboard will copy those cells. Then bottom left of the screen, I'm going to make a new sheet. And in that new sheet, I'm going to go Control-V, V as in Victor. Paste that in there. Control-V paste. And this one's going to be called relative. Yeah, so we're going to do relative change on this one. So if you double click where it says sheet 2, you can rename it relative. Enter to fix it. Lose you at any point, wave at me, call me, and I'll give you a hand. How you doing out there, Daisy? Doing okay?
Yeah.
All right. Just holler if you have a question. Are you using Sheets or are you using Excel?
Google Sheets.
Okay. So here, I need the absolute change to calculate the relative change, the way I did it there. Okay. There's other ways to do it we talked about yesterday. I'm not going to worry about that now. So what I want to do is I want to use this percent change to make the prediction instead of the absolute change. So I just want to draw that on paper first. So I copied over into my second sheet these first 3 rows of data all the way over to relative and put it in there. So
although I need absolute to calculate relative, I'm just going to ignore the 800,000 for now. 0.56%. So next thing we're going to do is we're going to look at how to use relative change. So, using relative change. For relative change, anybody? Percent change, yeah, it's also called percent change. So what we have at the moment is we have a percent increase about 13.56%. So to use that, I want to jump from 2010 to 2020. Population in 2010 was it 5,900,000? What was that? Oh, 2010. Okay. So repeat 6,700,000. Okay. Strong place. I'll get it later. So to do that, we have to bump it up, and we'll do this in two different ways. We have to bump that up by 13.56%. One way of doing that is just taking that 6,700,000 and multiplying that by 13% as a decimal, 0.1356. And then we have to add that back on to, because that's just the amount of change. We take that amount, we add it back on to the 2010 population to figure out what the 2020 population should be. So let's do that on the spreadsheet, and then I'll show you a different way to do that. So we're going to do this calculation right there on the spreadsheet. So spreadsheets. So 2020, I need to put a new row for that. Roll that up again. So for the population, I'm going to do a calculation, so I'm going to type equals. So I want to take the previous population, so click on that, and I want to multiply it by my relative change. Now, although the computer is showing me 13.56, it's actually storing more information than that, and it's going to use it in the calculation. Then I want to add on to that calculation. You want to try and make your formula look like that. Right. So we're reproducing this right here. We have to calculate the amount of change, so we have to take that 6.7 million and multiply it by the percent change. That gives the amount of increase. And we have to add that back to the calculation. Well, we already have the percent increase right here. We already calculated that. That's right here. Relative change is percent increase. So to use it, I take my previous population and I multiply it by the percent. That gives me the amount of change. So that tells me if we still increase by 13.56, that means the population is going to go up by 908,000. Now I have to add that 908,000 to my starting population, which is now 6.7 million. Okay, and that gives me a new population of 7,608,000. So we went up by a little more than we did before. Okay. So let's repeat that and do a 2030 just for fun. So same thing at each step. I go equals, I take the previous population, which is now the 7.6 million. I multiply it by my percent increase. That gives me the amount of increase. Now the population is going up by about 1 million people. And I have to add that back onto the 2020 population. Okay. So percent increase works the same way. So instead of just adding 800,000, we have to look at what the new percentage gives us. So we're doing a percent. And populations tend to increase in percentages They can't do that indefinitely, but they can do it for a while. So my new number is now 8,640,000. If you're having trouble getting that long, then I'll come over and read your video. Kristen's going all right? Yeah. Yeah, that's good. And then plus, and then come back to the 6 million on. I was hoping to have that done by this class, but I'm not quite done. So hopefully I'll finish it today and post it. Okay, let's see. Previous, multiply by percent. So we're going to graph these numbers to see what they look like, and then add on. The 2020 population. What's that? That's going on as another grade. It's not going to change your test grade. Yeah, so if you didn't give me your corrections yet, you need to. Okay, so next we need to graph this stuff, see what it looks like. So do you think it's going to be a straight line? Yeah, because we jump by a different amount each time. First we jumped by 800,000, then it was 900,000, then we jumped by 1 million. That's because we're doing a percent change instead of an absolute change. So there should be a slight curve to this stuff. All right, so to graph it, highlight A1 down through B5. If you wanted to calculate the absolute change? Yeah, I'll do that in just a sec. Hang on. Graph, we'll come back. Okay, so Emily wants to see how to recalculate absolute change for some other rows. Is that right? Yeah. Okay, yeah, we'll come back and do that. So let's just make a graph first. I highlight the data I want the graph to show. And I usually like to highlight the words too. I'll throw them in there for me. Not all the time, but most of the time. So then we go to Insert, and then Chart. Now you're going to go to Insert, and then you're going to go to Recommended Chart. For the kind of chart we want to do, if it didn't pick for us, we want to scroll through the types, and we want to get a scatter plot again. So now just a note on this right here. So I'm not going to put my labels in yet. I'm going to just scroll. Let's see. I'm going to go to Customize. Then I'm going to go to Series. And I'm going to ask it to put a line through there just to see if they line up or not. So to do that, from Customize, Series, I just say, hey, show me the trend line. Right? And you can see, hey, they don't quite line up. Right? Which is what we expected, because they weren't increasing by exactly $800,000 people over 10 years. Okay. So they don't quite line up. Now, when things increase by a percentage, we call that exponential growth. So exponential growth in our just on paper, and then we'll come back here. So I'm just going to abandon the spreadsheet for a moment. I'm going to go back to my worksheet. So we're just going to take a look at percent change some more, or relative change. All right. So we're still looking at using relative change, and there's another way to look at it. So each time we made that calculation, we took the previous population times the percent change, and we added that back onto the previous population. Another way to look at it is you could say the previous population, I'm just going to write that as times 1. So what I have here, if you think about the distributive property in reverse, I have the previous population. I'm going to pull that out. And that's going to leave behind the percent change plus 1. Now, what was my percent change? It was about 13%, right? So I'm just going to call that 0.13. Now, 0.13 plus 1, I can just call that 1.13, right? I can add that together, times the previous. So this is another way to calculate the new population. Now, didn't we repeat that over and over again? Yeah. So we kept taking the previous population. So this is now the new population, but in the next 10 years, that's the previous one. So what happens is, as we repeat this, over and over and over again,
all we're doing is repeatedly multiplying by 1.13, and again by 1.13. What happens when you repeatedly multiply? What do we call that in math? What's that? Powers, right? Exponents. Yeah. So essentially what we have here, so if we repeat relative change, R, then we end up with an exponent. So what we end up getting is equation ends up being your original population times 1 plus whatever your percent change is, raised to some power. And in this case, the power is the amount of years that went by. Now, we're doing every 10 years in our graph. So our P represents 10-year intervals. Okay. So let's just double check that. So if we start with a population, what was the 2000 population again? 5,900,000. Okay. If we look at our table, let's get this out of here, move that. From the original population, we jumped 1, 2, 3 times. So that means 3 multiples of 1 point approximately. Now here we have a few more decimal points, so I'll throw those in too to try and make it a little more exact. So I think that if we want to get the 2030 population, then we would take this and multiply by 1.13, I'm going to throw those other decimals, 5, 6, and raise it to the 3rd power. So see if you can type that into your spreadsheet or calculator. I'm going to type that into my spreadsheet. So come into your spreadsheet, and then just go off to the right here somewhere. So I'm just going to go out to column E in row 5. 5,900,000 times 1.1356. To raise a power, it's that little caret icon, that shift 6 gets you that. And I'm going to raise that to the 3rd power. And I should get pretty darn close to what the other calculation was by repeating the percent increase. Let's throw some commas in there so it's more readable. Drop a couple decimals. So 8,640,287. It's close, but not exact. Any thoughts as to why it's not exact? 1.1356. So I'm using the displayed version of the relative change there. Now, it's my belief that I should have gotten the same answer in column B5. Anybody have an idea of why it didn't come out exactly the same? Yeah, it turns out, although the computer right here is showing us 13.56, it actually is hiding the fact that it knows a lot more decimal places. And when we made these calculations, we didn't type 0.1356, we clicked on that cell, which means the computer was actually using all this other information to make this calculation. Okay. So all it is just a rounding error from here to here. So this answer is probably a little more exact if the 13.56 blah, blah, blah is accurate. But this one's in the ballpark. Right? What's 100 people out of 8 million? Not much. Okay. So we're close enough. We're in the ballpark. So again, depending on the calculator we use, depending on whether we round or just change the display, we're going to get slightly different answers, but we should be in the ballpark. But note, whenever we use relative change, that means we have a new increase each time. You didn't get that, Emily? You don't have enough zeros. All right, so we are out of time for fun with math. We're going to do more of this tomorrow. We're going to start working on the last few pages in the next class. This file, you're going to need it again. If you need help saving it, let me know. You could just upload it into Canvas for now and then retrieve it next class. So to do that, first save it, and then go to the lesson 7 to update. If you're in Google Sheets, you already got it. Don't worry about it. So just going to say browse. Sure. 27.
All right. Have a good day, Daisy. Oops, she left before I could wish her goodbye.